Good morning. Yours truly, Professor Dolphy Gilpin here in the theatre hall, family theatre hall, La Vista in Decatur, Georgia. And this morning we're going to quickly build a pyramidal structure and use it to supply the coefficients of some binomial expansion. So let's put over here, we're going to be expanding x squared, and then we're going to supply the coefficient. X square, no, x plus 1 square, x plus 1 cube, x plus 1 to the fourth, x plus 1 to the fifth, and so on. But first we're going to build a pyramidal structure over here, and shown over here, but we're going to try to make it more explicit over here and supply the coefficient of these. First we know that we're going to have, this is x to the 1, or really x plus 1 to the 0, x plus 1 to the 0. And then we're going to supply the coefficient. X plus 1 to the 0, x plus 1 to the 1, x plus 1 to the 2, x plus 1 to the 3, and so on. So this is x plus 1 to the 1, x plus 1 to the 2, x plus 1 to the 3, 4, 5, and so on. So it'll be like x plus 1 to the 6. All right, the pyramid is go like this. You're going to have 1. Let's put it over here, right? 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1, and 1, 4 and 1, 5, 6 and 4, 10, 6 and 4, 10, 4 and 1, 5, and 1. This would be 1, 6, 6, 4, 1 is 5, 6 and 4, 10, 6 and 4, 10, and 4, 1, 5. And this is 1, 4, 1, 5 and 1 is 6, 10 and 10 is 20, 10 and 5 is 15, 1. So these would be the coefficients. So for example, we have now x plus 1 to the 1. That will be simply equal to x if we expand it out, coefficient for the 1, and this would be 1 also. So x plus 1 square, we know that we're going to have x squared, we're going to have an x to the 1 and an x to the 0. But for the coefficient, we go to this here, and we say this would be 1, and this would be 2, and this would be 1. Note that anything to the 0 is 1. Y to the 0 equals 1, n to the 0 equals 1, z to the 0 equals 1. Anything raised to the power of 0 is 1. So x plus 1 cube, x plus 1 cube equals now, you're going to have a cube, x cube, we're going to have a square, we're going to have a 1, we're going to have x to the 0, which is 1. So to supply the coefficient, we go to the pyramid and say for 3, this would be 1, 3, 6, something is missing here. Now it will be, we should be using this one. So let's go back and say this will be x cubed, x squared, x1, and x0. And for this one, we go here and say this will be 1, 3, 3, 1. And we could build this pyramid as large as possible. And so we could, if you want x plus 1 to the 7, x plus 1 to the 8, and use the same principle and supply the coefficient of the expansion, of the corresponding expansion. That's to Professor Dolphy Gilpin. I remember getting this pen in Minneapolis, Minnesota, at a Barnes & Noble bookstore. So my little pen here compliments of the Barnes & Noble bookstore in Minneapolis, Minnesota.